Welcome to lesson 74. We're going to talk about Cramer's rule. Who is Cramer, you might ask? Cramer is Gabriel Cramer, and he published this method in 1750. Most mathematicians are intrigued by the patterns and the relationships that are found in math. And there are a lot of patterns. And that is one of the things that rings true for me as a math teacher and someone who's just interested in math, is that these patterns exist and they're always consistent, which to me points to a creator. Random acts, what we consider to be random things, aren't specifically designed. They're just they happen, right? But something that is consistent and true every time is typically the work of someone who has laid out a plan. So that points to me to God being the creator of our world, because it is consistent and these patterns exist within the mathematics, and they existed before we found out they were there. Right? This is not something that man created. This is something that God allowed us to find within his creation. So that it clarifies and points to the presence of a creator for our world. So I digress. Let's talk about Cramer's rule. So Cramer studied math, and he decided he found that there's a pattern when solving linear equations. And that pattern, we've already discussed about how we can multiply, we can sub in variables for the values in a system of equations, and how we can then solve for that using the variables and come up with a formula that allows us to just multiply. Not even solve, but just look at the coefficients, much like we do for the quadratic formula. We just pull the values for the coefficient and factor it in. We multiply it and then we solve without having to actually do the math that goes along with it, without having to do the long way. It's like a shortcut that's consistent and true. And you can see here I've displayed Cramer's discovery, Cramer's rules here, in that x is equal to dE minus dF over dA minus BC. When we solve that, we can solve for x without having to do anything other than look at the original equation and pull the value for A, B, C, D, E, and F from the coefficients that are given, and then put them into this format and solve. Same thing is true for y. We can solve and create a formula for y that allows us to look at the coefficients, drop them into this formula, and solve without ever having to actually do all of this elimination and multiplication. We can do it the short way, much like we do for the quadratic formula. It's the same principle as the quadratic formula. So Cramer's rule dictates, or it says, that looking at a system of equations, we can sub in these values, A, B, C, D, E, and F, in the form of a matrix. And because the matrix by itself proves true, when it's combined then with the values in a system of linear equations, guess what? It remains true. It reacts and acts exactly the same way. The rules still apply. We cross multiply and then subtract. So this one is positive, this one is negative. So ED, E times D minus F times B, or BF. And that's going to be divided by A over D minus C over B. Okay? And then y is equal to a times f minus c times e, divided by a times d minus c times b. So take a minute and jot these all down. And we're going to solve a system of equations. Actually, I think I'm just going to roll it up a little bit. And we'll solve 74.1 using Cramer's rule. So 74.1, here's our system of equations. We have 3x plus 2y equals -1, and 4x minus 3y is equal to 10. All right, so this is A, B, C, D, E, F, right? So let's do x. X is equal to, let's do our matrix here, over matrix here. So A, B, C, and I wrote C. I didn't write the value. Ha! Losing my mind. C, D. And then this is going to be BD, so 2, -3. So this side remains the same. This side, this is your coefficients just the way they're written. And then this is going to be the same as it is down here, but then we put EF, -1 and 10, right there, the way that it's written right there. All right, so the middle is the side here, the right side on the top and the bottom. And then the left, you take the answers and then the first coefficients. Does that make sense? So the answers, first coefficients, middle coefficients, exactly the way they're written. Now we can solve. So we're going to say -1 times -3, that's going to be a +3, minus 10 times 2 is 20, over 3 times -3, that's going to be -9, minus 4 times 2 is 8. So that is a -17 over -17, which equals +1. X is equal to 1. Or I guess I should just go ahead and write that as a point. So X is 1. So let's find out if Y is the same. Okay, let's do Y. So Y would be written in our system like, let's put our matrix down here, our matrices. So for Y, the first terms are duplicated. Okay, for X, the Y terms are duplicated. For Y, the X terms are duplicated. So 3, 4, 3, 4. And then we have the answers still on top, both times, and then B and D. Okay, so that is the difference. The difference is for X, the Y terms are kept on the right, and then you have the answer over the X terms. For Y, the X terms are kept on the left, and then you have the answers over the Y terms, if that helps you understand or see it better, remember it. So let's do our multiplication. 3 times 10 is 30 minus 4 times -1. So that'd be a -4. So that's going to be negative is a positive, right? So then we have 2 times negative, or 3 times -3. That's going to be -9. 4 times 2 is going to be -8. So the denominator remains the same regardless. So 30 plus 4, that's going to be 34. -17. That's going to be equal to a -2. So Y is -2. Man, that was faster. How cool is that? So let's check our answers. And that's exactly what the book says. The book says that our answer is going to be y, or 1, negative 2 for 74.1. So let's try that again and see if we can remember how to do the system all by ourselves. So I'm going to rewrite this system for Cramer's rule as a way, in a way that helps you solve a little bit easier. So x is equal to, here's our matrix. So given the system of equations, you're going to do y1 over y2, y1 over y2. This is going to be x1, x2, and this is going to be, let's call this answer 1 over answer 2. All right, and then that is going to give you a1 times y2 minus a2 times y1 over x1 times y2 minus x2 times y1. That is x. So y is going to look like, here's our matrix, x1, x2, x1, x2, answer 1, answer 2, y1, y2. So you can see how it's formatted. The denominators remain the same. They're exactly what the coefficients are in the way they're written on the left side of the equation. Okay, and then for x, you take the answers and the y's. For y, you take the x's and the answers. And then that's going to equal x1 times a2 minus x2 times a1 over x1 y2 minus x2 y1. All right, so let's look at 74.2 and see if we can solve. And let's do 74.2 and 74.3 very quickly. All right, so let me put those up here. All right, so here are our 2 remaining problems, and then we're done with lesson 74. So let's use Cramer's rule to solve for x and y. So I'm not even going to look at this matrix. I'm going to look at this right here, and I'm going to find my way to solve that way because I know that the matrix just shows me how to do this, right? So a1 times y2, that's going to be negative 35. I'm sorry, I did that wrong. A1. A1 is 1. 1 times negative 3 is going to be a negative 3. And then negative 17 times negative 7 is going to be negative 51. Did I do that right? I did not do that right. All right, so I need to look at it a little bit better. Okay, A1 is this answer. I didn't do Y2, did I? I did Y1, so that's what I did wrong. So this is going to be negative 7, and this is going to be minus 51. Then this is going to be X1 times Y2, so it's negative 35. And then 2 times negative 3 is minus 6. So that's going to equal negative 58 over, I'm sorry, this is minus a negative 6, so that's going to be plus 6. So that is going to be negative 29. Negative 58 divided by 29, that's equal to a positive 2. So x is 2, and then y is going to equal, let's look at y, that would be x1 times a1, or x1 times a2. 5 times a negative 17 is going to be a negative 85. And then 2 times 1, that's going to be minus 2. Then x1 times y2, that's going to be negative 35. And that's plus 6 because the denominator remains the same. So that's going to be a negative 87 over negative 29, which is equal to 3. So the answer here is 2, 3. That was a lot faster. Once I wrapped my head around what I had to multiply times what. So keep this in your notes and use it as a handy reference so that you can see what's going on. So let's do the second one. So the first thing I notice is 3x plus 2y and 3x plus 2y. Those are going to be exactly the same slope. That's going to be 3 over 2. So that means that because these are exactly the same slope, these are going to be parallel lines. So I don't think that we're going to have a solution, but let's check it and see, just to make sure. X is going to be equal to x1 times a2. So that's going to be 24. Oh, I'm sorry, that's y. a1 times y2. So a1 times times y2, that's 10, minus, and then a2 times y1, a2 times y1, that's 16, over x1 times y2, that's 6, minus 6, equals negative 6 over 0. Guess what? That's undefined. So there's no solution there. So right away, we can't find a value for x. And that's because, like I said before, these are parallel lines. Because if you were to solve for y, you would move this over to be a negative 3x, and then you would divide it by 2 to be a negative 3 over 2x plus 5. Same thing, because it's exactly the same problem, you would have negative 3 over 2x plus 8. So that means that you're going to have a slope of negative 3 over 2. One of these is going to intercept the y-axis at positive 5, and the other one's going to intercept the y-axis at positive 8. So there is no solution. You don't have an intersection of this system of linear equations. So you can't solve this one using this method. Well, you can't solve it using any method. All we know for sure is that we have two parallel lines here that never cross. So that would be the solution for 74.3. No solution. So when the determinant of coefficients of a system of linear equations has a value of 0, the system does not have a unique solution. So that's all we have for lesson 74. All you have to remember is put in these formulas, right, to show you which ones. And all we're doing here is we're looking at the x values, the y values. This is the first system, or the first equation in the system. This is the second system in the equation, or equation in the system. I got that backwards. So you're going to look at, this would be x1, y1, answer 1, x2, y2, answer 2. And that would be mapped out to both your values for x and y. Right? So that's x1 minus y1 equals a1. And then x2 minus y2 equals a2. And that's how you would refer to this and this. And I do x and y just because that's what you're going to see. You're going to see the x and the y term. We just use the coefficient for each one of them. But that's going to help you keep it straight a little bit better, I think, than the A, B, C, D, E, F. All right. I will see you in lesson 75.